Revisiting the loneliest planet, Neptune. Neptune is the loneliest planet in the solar system, located at the edge of our solar system, far away from the rest of the planets. Despite its isolation, Neptune is an incredibly fascinating world. Being the last planet in our solar system, exploration of Neptune has been pretty limited. But the future of human exploration holds immense possibilities. There are many missions planned by NASA and other space organizations to various destinations in our solar system. But what about Neptune? Can we revisit the planet in the coming years or decade? What can the blue icy giant teach us about the solar system and its origins? In this video, we will talk about all of that and more. Neptune is the only planet in our solar system that is not visible to the naked eye, and its atmosphere is composed of hydrogen, helium, and methane, giving it a bluish hue. The planet is believed to have a solid core surrounded by an ocean of liquid water and ice. The exploration of Neptune began in 1989 when the Voyager 2 spacecraft made its flyby of the planet, providing us with the first close-up views of its mysterious atmosphere. NASA's Jet Propulsion Laboratory in Pasadena, California, was humming with activity on August 25, 1989. Scientists, media, and even a rock star, Chuck Berry, had gathered at the facility's mission control the night before to honor the moment the Voyager 2 spacecraft sailed less than 5,000 kilometers over Neptune's North Pole, marking its closest visit to the ice giant. The level of excitement was through the roof. The excitement had been building for more than a year as the spacecraft neared what is now thought to be the Sun's most distant known planet. Exhilaration built day by day as Voyager 2 returned images, gradually converting a fuzzy collection of pixels into a huge, gorgeous blue orb. It got to the point where every time a new batch of photographs was released, there were fresh discoveries on the planet. The Voyager 2 marked an important milestone in history and was the first and only spacecraft to make observations of Neptune. Each image taken by Voyager 2 revealed an unusually active environment, complete with methane-rich clouds, ferocious storms the size of Earth, and planetary winds that exceeded 2,000 kilometers per hour, the fastest in the solar system. The data that was gathered during its flyby was invaluable for scientists. Voyager 2 found that Neptune was home to an atmosphere made up of hydrogen, helium, and methane, and it was also able to detect the presence of a faint ring system around the planet. This was a major discovery since the rings were not previously known to exist. It also discovered several moons orbiting Neptune, including Nereid, Triton, and Proteus. These moons were found to have icy surfaces, and Triton was determined to be the coldest known moon in the solar system. Triton, Neptune's massive frozen moon, was churning with geysers and other unexpected evidence of geologic activity. Voyager 2's flyby of Neptune also allowed scientists to better understand the planet's magnetic field and its dynamics. The spacecraft found that the planet's magnetic field was offset from the planet's center by about 45 degrees, and that the field was tilted by 47 degrees from the planet's axis of rotation. This was an important discovery since it was previously thought that all planetary magnetic fields were centered on their respective planets. But then Voyager 2 moved on, leaving Neptune alone, just as it had done with Uranus, our solar system's second ice giant, after flying past it in 1986. Since then, researchers have continued to explore and study the characteristics of Neptune. In 1994, the Hubble Space Telescope was able to observe Neptune's Great Dark Spot, a large storm system similar to Jupiter's Great Red Spot. The Cassini mission also provided us with more detailed images of Neptune's atmosphere and moons, including Triton, the largest of Neptune's moons. Despite all this exploration, there is still much that we do not know about Neptune, and there are many potential areas of exploration for future missions. One of the most intriguing mysteries is the origin of Neptune's Great Dark Spot, which may be related to the planet's internal structure and composition. Another interesting area of exploration is to study Neptune's moons, which could provide us with more insight into the evolution of the solar system. In addition to studying Neptune's atmosphere and moons, future missions could also be sent to study Neptune's rings. It is believed that Neptune has a ring system similar to Saturn's, but much of it is still unexplored. Understanding the structure and composition of the rings could give us further insight into how the solar system formed and evolved. Finally, future missions could also be sent to study Neptune's auroras. Auroras are caused by charged particles from the Sun interacting with the planet's magnetic field, and they can provide clues about a planet's interior structure. By studying Neptune's auroras, we could gain further insight into the planet's internal structure and composition, as well as the relationship between the Sun and Neptune. There are many exciting potential areas of exploration for future missions to the loneliest planet in the solar system, Neptune. Understanding the structure, composition, and evolution of this mysterious planet could give us further insight into the formation and evolution of the solar system as a whole. Luckily, the exploration of Venus is gaining traction once again. A second expedition to these chilly and strange planets might be launched quite soon, thanks to growing enthusiasm from the planetary research community and fortuitous timing. That is not to argue that scientists have not conducted research on Uranus and Neptune on Earth. To study such remote giants, astronomers often turn the mirrors of enormous telescopes on the ground and in space toward the solar system's boundaries. However, from such large distances, Uranus and Neptune appear as tiny blobs. As a result, it has required a variety of techniques to better photograph them. Scientists have fired lasers into the night sky to improve their images, analyzed Triton's atmosphere as it passed in front of a distant star, and conducted experiments on Earth to better understand the strange ice that resides inside these worlds. However, these efforts are insufficient. The problem is that although trips beyond the outer solar system are feasible, they're not easy, in part because they take at least a decade. It is much simpler when you can design and deploy a mission within 2 years. The funding for such short missions can be secured easily. It's easy to design and launch too. Long-term missions, especially to such large distant objects, requires everything to be perfect, or you could lose the entire mission. Furthermore, distant from a star, a spaceship cannot rely on solar power and must instead rely on nuclear fuel, such as plutonium-238, which provides a constant heat supply and is a perfect power source for dark missions. However, NASA's purchase of that radioisotope has been irregular for a long time. NASA's nuclear revitalization could not have come at a better time. To begin, there is little doubt that such a journey will transform our understanding of the outer solar system just by traveling there after 3 decades of technical advancement and scientific discoveries. Furthermore, the planets will be positioned in the late 2020s such that a Neptune-bound spacecraft may receive a gravitational assist from Jupiter, gaining immense speed by swinging past the big planet and cutting years off the voyage time. Finally, in order to glimpse Uranus's northern hemisphere for the first time, a mission to the planet must arrive before 2050. On the flyby of Uranus by Voyager 2, only the planet's southern hemisphere was lighted. Recent Kepler Space Telescope discoveries add to the case for exploring the solar system's ice giants. Based on Kepler's investigation of other planetary systems in the Milky Way, astronomers are almost positive that ice giants, a distinct and different form of globe when contrasted to rocky planets and gas giants, are the most prevalent in the galaxy. Without a deep understanding of the Milky Way's most numerous residents, our comprehension of how planets are created, evolve, and perish would be tragically lacking. Yet the ice giants contravene many of our most reliable theories of planetary formation, which predict that such planets should have evolved into full-fledged gas giants like Jupiter, but they didn't, and scientists aren't sure why. Furthermore, scientists believe that water in the form of ice makes up the majority of the inside of a typical ice giant, hence the name, although confidence on this essential feature remains elusive. We know so little about Uranus and Neptune that we need to go back and finish the work for the ice giants before we can truly grasp the exoplanets. There are currently several proposed missions to explore Neptune and its moons. The first of these is the Neptune Odyssey mission, which is under scientific review. This mission will use a robotic lander to explore the planet's moons, Triton and Nereid. The lander will study their geology and chemistry as well as the composition of their atmospheres. It will also take images of their surfaces, providing us with a better understanding of the composition and internal structure of Neptune's moons. Another proposed mission is the Neptune Orbiter and Remote Sensing mission, which can be launched somewhere in 2035. The mission will use an orbiter and a lander to study Neptune's atmosphere and magnetosphere, in addition to its moons. The lander will search for evidence of possible life, as well as explore the surfaces of the moons. These proposed missions are just the beginning. In the future, more missions to Neptune are likely to be proposed. This could include flybys, landers, and orbiters, as well as robotic probes to explore the surface of its moons. All of these missions will help us to better understand this distant, mysterious planet and its moons, and will provide us with more detailed information about the composition and conditions of this lonely world. Neptune may be the loneliest planet in the solar system, but with the upcoming missions, it will soon be much less lonely. These missions will help us to better understand this distant world and will provide us with unprecedented information about its environment and the potential for life beyond Earth. So what do you think about humans revisiting Neptune? Is a mission to the blue icy giant long overdue? Let us know what you think in the comment section below and share the video with your friends.